Hello everyone. So we already have started discussion regarding sensor physics, and before that we have discussed different sensor parameters. In sensor parameters, we have seen that there are various parameters associated with sensors that are important. For example, say sensitivity, range, then calibration curve, etc. And then we also started discussion regarding sensor physics, how different sensors work. So in this direction, we have seen that there can be capacitive sensor, there can be temperature sensor, so on and so forth. Now, when we have started discussing those sensors, we have done a theoretical discussion regarding how these sensors, how do they work, how do these sensors work. And then we also briefly mentioned what are the packaging associated with the sensor, how they are packaged, how they are sold. If you take a commercial sensor, you'll find that the sensing element is inside certain kind of envelope or coating. The sensing element is inside that envelope, so that the sensing element is protected. Then different terminals are connected with the sensing element. This is a typical kind of structure of a sensor, two terminal sensor. And then if it is three terminal or more terminal are associated with the sensor, then you also find different types of packaging that you usually see in an IC. Today we will try to see different types of sensors so that we get a very comprehensive idea about how they look like, or what are the different kind of components present in the sensor when we see it, right? So to begin with, I've taken an example of a thermistor, which is a temperature sensor, and in the thermistor you can see that a number is written 103, right? So it actually depicts the characteristics of the sensor. In this case, it's a 10 kilo ohm thermistor. That means the base resistance of this sensor is 10 kilo ohm. You'll find that the temperature, the resistance of this sensor in room temperature is around 10 kilo ohm, and it has two different terminals. Both the terminals are made of metal. And just to give you a better idea, what I've done is I've crushed this sensor. Now in the video you can see that the terminal, this metal terminal, is connected to the active material. Now in this case, the active material is inside. The shiny material that you see inside is the active material. Usually these thermistors are made of metal oxide like nickel, manganese, so on and so forth. And then this metal terminal is connected to this active material, and there are two different terminals likewise, and then they package it with certain sort of encapsulation, right? So this is a typical example of a thermistor and how this temperature sensor looks like, and how these electrodes are integrated with the sensing element. Now here also you can see very clearly, this is the electrode and these are the kind of active material, right? And then they encapsulate with certain sort of material which is black in color again on top of it, and that is how they make it. So this is one type of sensor. There are similarly very different or other types of sensors present commercially, and each of these sensors have their own packaging, right? It is not necessarily same packaging for all the sensors. This is just an example, just to give you an idea, a feel about the sensor, how it looks like in practice. I have shown you that video. Similarly, if you want to see how these sensing element inside the sensor looks like, we can take a microscopic image. So what I have done is I have put this thermistor under a microscope and then tried to focus different areas of the sensor. Now in the video itself you can see that there are different shiny parts. These are the active materials present inside the sensor, and you also can see that the entire picture is not focused at a time, because if you look at the image shown over here, it's not like uniformly kind of cross section or dissection. So that's why you'll find that at certain point some portion of the sensor is like focused, some other portion is defocused. Okay, so these are the microscopic view of the sensor, and these shiny parts are actually your active material, and then these active materials are coated with a kind of encapsulation, and then you have metal electrodes connected to that. So usually you have two different electrodes, and it's a 2 electrode system or sensor actually, and I have said that it's a example of a temperature sensor. So you can see different areas of the sensor under a microscope as it is shown over here. These are the active materials. So this is how it looks. See, this is the sensor structure. However, this part probably is this one where the encapsulation can be seen, right? This is how it is encapsulated, and then this part is the broken part, right? So you get a better idea now about how these thermistors look like. Similarly, as we have discussed before, in this case we have taken an example of a thermistor. A thermistor can be PTC and NTC. PTC means positive temperature coefficient or positive thermal coefficient, and NTC is negative temperature coefficient or negative thermal coefficient. In this case, the sensor that I have shown you is an NTC type of sensor. That means the resistance of the sensor decreases with increase in temperature. So we have taken an example of NTC type of sensor, that is, the resistance of this sensor should decrease with increase in temperature. Now just to show you that how this response looks like, so we have taken an temperature sensor, that means the thermistor, the one that we have just seen in the previous video, and we have connected this with a multimeter. Now you can see that the initial resistance is kind of 9 kilo ohm or so, which is the base resistance at room temperature. It should be around 10, but anyways room temperature varies. If the temperature is bit higher than whatever is written in the specification sheet, you will find that the resistance is bit lower than what is reported. So in this case the base resistance was 9 kilo ohm, and then the moment I have touched the sensor, the moment you touch it, in the video you will see that the resistance will start dropping, right? So initially it's like 9 kilo ohm, and then when you touch it, the temperature around it will increase, and see the numbers start decreasing. That means it decreases from base to lower values. The moment you remove the hand, again the temperature, the resistance value will start increasing, because the temperature is now dropping. It is again coming back to the room temperature situation. So that's why you'll see that the resistance of a thermistor decreases when you increase the temperature. Similarly, I also have taken another example, which is an LDR, light dependent resistor. So this is the basic geometry of an LDR. You have two terminals, these are metal wires, and then you have metal electrodes as it is shown over here, and then you have a active material in here. The serpentine kind of structure that you can see over here is like the active material. Usually it is CDS or CDSE, that means cadmium sulfide or cadmium selenide, and the entire sensor is made of or is made on a ceramic platform, that is this one. Okay, then you weld these metal terminals with the electrode as it is shown over here. So this is the basic geometry of an optical sensor, which is popularly known as LDR, that is light dependent resistor. Now in this case also, if this sensor is exposed to light, then the resistance associated with sensor will decrease. In dark condition, the resistance is high. The moment you expose this to light, the resistance will decrease. So this is how this LDR behaves. Now here I have shown you, or here you can see the video of this LDR. This is the ceramic platform. These are the two metal wires, and then this is, the small dots are like the metal wires that are connected with the electrode using cold welding, and then you can see the active material also in the middle, this serpentine structure. Okay, so it's like actually interdigitated electrode, and then beneath that electrode you have the active material. Okay, so electrodes are anyways connected to the active material. So the moment you expose this sensor to light, then lot of carriers will generate. We already have briefly discussed in the sensor physics regarding this phenomena, and then you will see in turn the resistance is decreasing. So these are the metal wires, this is the ceramic platform, this is the active material. You can see the brown color thing in the middle. These are the interdigitated electrodes, and this is how you connect those wires with the electrode using a cold welding. Okay, now let us again see the microscopic image of the same. So you can see here, this is the metal electrode that is welded on top of the electrode of the sensor. This is the electrode material, this is where the active material is. Now when we focusing and defocusing, you may see some shiny thing over here. This is the protective layer on top of the sensor. So there is a small protective layer also on top of the sensor. That's why when we focus and defocus, you may find that there is another layer which is a bit shiny. For example, in this case, see in this case, right? So this is the protective layer, a very thin layer of say a polymer which protects the sensor from environment. And then these are the brown colored thing is the active material. Okay, and these are the electrodes. You know, the silver colored things are the electrodes, and then here these are the active materials. So this is how a LDR or light dependent resistor looks like. Again, we have performed a very basic experiment with the sensor. We connected the sensor with multimeter, and the moment you connect it, it shows the resistance in that lighted condition. So that is how you connect it. Now if these are connected, make sure these two terminals are not touched. Okay, if they are touched, then you'll see a zero resistance. However, in here you can see when it is in the lighted condition, it is giving an resistance value which is very high. So initially, now just you have seen that when they are touched, it's like 0 kilo ohm. So this should not be touched. Now the moment you touch it, you touch these two electrodes, the response will be 0, right? So this should be separated, right? That one has to be carefully do the experiment. And just now, as you have seen, that when this is in the lighted condition, or when it is exposed to light, the resistance is around 7 kilo ohm. The moment you cover the sensor with your finger, the resistance increases to around 50-60 kilo ohm. We will again try to see the video. So this is the sensor. You connect two electrodes with the two terminals. So now these two are connected. Make sure these two electrodes are not touched with each other. Okay. Now in this case, see, when you touch it, the resistance increases. When you leave it, it's like 7 kilo ohm. See, now the resistance is 0 because these two terminals are touched with each other. Now if you touch it, the resistance will be 0. See, no response. You will see no response. So you have to make sure that these terminals are not shorted. The moment you take it out, again, the moment you put the finger on top of the sensor, it goes to around 60 kilo ohm. You remove the finger, see, it's around 65 kilo ohm. You remove the finger, it comes back to around 7 kilo ohm, right? The moment you put the finger on top of the sensor, that means it's a dark condition. The sensor is no longer be exposed to the light. That's why the resistance increases to 60 kilo ohm. The moment you remove the finger, again light falls on it, the resistance quickly drops down to 7 kilo ohm or so. So this is another example, a basic experiment associated with a optical sensor, that is LDR. Now this is another sensor. It's a module actually. It has a temperature and humidity sensor inside this covering. Okay. So this is another example of a sensor. You can see this time these multi sensors are connected with different other components. So it's kind of a module. We call it a sensor module. And then you connect two different sensors in that module. In this case, it's like temperature and humidity. And you can see that the entire module is not very big, it's actually small. Okay, and then this particular sensor module has three different terminals. One terminal is for ground, and then one terminal is for VCC, another terminal is for the data. Okay, you have to connect it accordingly. And this particular hole is for connecting the entire module with a, say, PCB or something. That's why they provide it. And this is a covering, this is a plastic covering. Inside the plastic covering, you can see here a small sensor is visible. This is a humidity sensor. Then you also have a temperature sensor in it. Okay. So here I am giving you the microscopic image or microscopic video of the humidity sensor. So you can see the sensor here. So in this case, this is one electrode. Then you have an active material in the middle, and then you have another electrode at the back side of it. Okay, so this is the microscopic video of the electrode. So it's like a bit porous kind of. Okay, and then here you have the metal wires connected. So this is how it looks like. This is one electrode. At the back side also you will have another electrode. Then you have another material in the middle. So just to provide, and this is the image of the sensor. It's very small. So this is an example of a capacitive humidity sensor. So this is when you break it. So you can see this is one material. Then this is the top electrode. This is the bottom electrode. The shiny metal plate kind of thing. Okay. So this is another microscopic video of the sensor, or I would say the sensor electrodes. You can see different structures on that sensor. This is when you are zooming it. Okay. So this is another example of a sensor. Now this is how it looks on the other side. This is another electrode, on top of that the sensor was there. Okay, you are zooming it now. So once you zoom it, you'll get a better image in terms of different structures. So this is the top electrode one, this is the material in the middle, and then you have another electrode at the back side. This is when you zoom it further. So you can see different structures in the video. So this video is made to give you a idea about how these sensors look in under microscope, or when you procure it, how they look and what are the arrangements. So just to provide you that information. So this is the electrode at the back side, this is the top electrode, then in the middle you have another material. This is where you connect your metal electrodes, metal wire electrodes. So this is a structure of a capacitive humidity sensor. Okay. Now this is another sensor module, which is kind of IR sensor module. So you have a IR detector and a IR source, and then these are the other components present in the module, because when you make a module you have to calibrate the entire sensor for that module so that one can directly use it. So in this case you have an IR detector and you have a IR source. So when the IR source sending a signal, it reflects back from some material and then will come back to the detector. So from that you will be able to detect, say, distance or different other parameters. So you can use this module for various purposes, for various applications. So this is a module, and you have these 3 electrodes. Again it is written, this is output, this is ground, and this is like VCC, that is the supply voltage. And then you can use this module to a circuit for developing a system. Okay, and these are the sensor. This is the detector and this is the source. Okay, this is a microscopic image of sensor module components. So there are different SMD components. SMD meaning surface mounted devices. So these are all SMD. This is the image of this particular circuit. So you can see that at various places you have different components, different electrodes. So if you put these or put the circuit under microscope, you'll be able to see different parts of this circuits in a microscope. So this is how the electrodes look, this is how the interconnects looks like. So one has to be very careful when they make those modules, because if these electrodes are very close to each other, while soldering, if you end up shorting one electrode with other, then definitely you will not get the response. So this is again a microscopic video of a circuit, just to give you an idea how it looks. In the upcoming discussion, we will again discuss some of the sensor physics, and till then, thank you.